The both arm and thumb instruction within the same program. So why we need to mix the program, the instructions, both instruction in a same program, is the certain application, certain portion of that application having the bulk of code, that portion of the program has to be written using thumb instruction sets that gives the minimum code size. Then certain portion of the application requires high performance, where that portion of the application is the performance is the critical part. That part has to be written using ARM instruction set that gives the high speed. So if the microcontroller has to execute the both ARM and thumb instruction set, then the microcontroller has to be the both state, ARM state and thumb state. Whenever the microcontroller is executing the ARM instruction, then the microcontroller should be in the ARM state. When the microcontroller executing thumb instruction set, then microcontroller has to be in the thumb state. So there is a need of changing the state. The microcontroller has to be changed the state from ARM state to the thumb state, or thumb state to the ARM state. So changing between, that is switching between these two states, is called ARM thumb interworking. The ARM thumb interworking handles the transition between the two states, that describes how to change between the ARM state and thumb state. The changing the state between the ARM state and thumb state involves the one is the first case. There are two cases. One is change from, the microcontroller has to change from ARM state to the thumb state. Three steps. One is the set the state of the ARM microcontroller, that is by changing the T bit of CPSR register. Means T bit of the CPSR register has to be set to 1. Then microcontroller, ARM microcontroller will enters to the thumb state. Then after that, the microcontroller has to change the execution flow from the ARM instruction execution switch to the branch to the instruction, thumb instruction subroutine. So before branching to the thumb instruction set to execute, after completion of the subroutine, completion of the thumb instruction subroutine, then microcontroller has to come back to the remaining ARM instruction set. For that, we have to store the return address. So for that, we have the another step is set the return address in link register, particularly link register. And third is branch to the subroutine, right? There are three things. One is change the state of the ARM by changing the T bit of the CPSR, and secure the return address. That is because in generally we have to store the return address even executing the subroutine, calling the subroutine. After completion of the subroutine, where that the execution flow has to come back, it has come back to the main program, where the next instruction of the branch instruction to be start executing. Then another case is after completion of the thumb subroutine execution, it has to come back to the ARM instruction execution, right? That is changing from the thumb state to the ARM state, means switching from the thumb instruction execution to the ARM instruction execution. It is having the two main steps. One is set the T bit of CPSR to 0. The previous case, to enter the thumb state microcontroller, T should be 1 for thumb, T should be 0 for ARM state, right? So then branch to the return address. That return address is stored in the link register in the here the T return address storage that has to be branched to the brand to the address which is stored in the link register as a return address. So now we have to look at the what we made the previous slide, the statement that the programmer can write as the both thumb and arm instruction in a single program. So here this is called a complete program. In that the both instructions are there. So here this is the portion for arm instruction set, right? And this is a portion of thumb instruction set, right? So as of now, assume that the microcontroller is executing the arm instruction set instructions, then the microcontroller has to execute the thumb instruction set. For that, the microcontroller has to change its state, and then so this is the first step is load the address where thumb instruction into the one register, that is R0, and this is the instruction to store the return address, which is the PC. The content of the PC will be what it will do is it will copy the address of this instruction because this will be the return address. Then next is to run the branch instruction. So what it will do is the BX instruction is a branch exchange instruction. What it will do is whatever the content of the R0 is copied to the program counter, then and also whatever the least significant bit of R0, that is a 0 bit of the R0 the content of that 0 bit of the R0 will copy to the T bit of CPSR. So this is the operation performed by branch instruction, right? So that's why instead of loading the thumb address into the R0, here we specified that +1. +1 means +1 is included in the 0 bit of R0, so that while executing the BX instruction, that 0 bit is copied to the T bit of CPSR register. So while branching from the arm instruction execution to the thumb instruction execution, we need necessarily use these three instructions, right? Once a branch, then the arm microcontroller enters the thumb state and start executing the thumb instruction set. After completion of this routine, we have to branch back to the arm execution, right? So this is the instruction branch. LR is already we stored as a return address. Then after completion of this, the program will come back to the instruction which is after the branch instruction. So here this is how the arm and thumb interworking performed, right? So let us look at that few instruction. Already we know that code 32 is a assembler directive which instructs the assembler to interpret whatever the subsequent instruction which is written after the code 65. That instruction has to be considered as respective instruction set. If it is a code 32, means whatever the subsequent instruction after the code 32, consider it as encoded it as, interpreted it as 32 bits. Then whatever you are written instruction after the code 16, means assembler will interpret as the thumb instruction set, means each instruction size will be 2 bytes. So this is how. So let us look at the load thumb R0 here. The address of this will be loaded into the R0, and then +1 is set because this 0 bit of the R0 is used while branching. That one